Hello, pre-calculus students. This is Mrs. Raposa, and this is your first lesson from Chapter 2 of your pre-calculus book. And in this lesson, you're going to be able to determine whether a function is a polynomial function, evaluate the function for variable inputs using substitution, synthetic and direct substitution, and you're going to determine the zeros of the function. Well, first of all, our book tells us a polynomial looks like this, and I would tend to disagree a little bit because this looks more like a polynomial than this does. But let's break this down and see why this does represent a polynomial. First of all, the n minus 1, and n minus 2, those are all just exponents. And in order for it to be a polynomial function, all of those exponents that are on the variables must be positive integers, so whole numbers. No decimals and no fractions, and no negative numbers either, no negative exponents. If it is a polynomial function, well, even if it isn't, the coefficients are the numbers that are in front of the variable to some exponent. Like over here, the coefficient is 2. So let's take a look at what we'll also be looking at, which is what is the degree of the function? The degree of the function is just the highest exponent. That is, if it is a polynomial function. Polynomial functions, we don't talk about what degree it is unless it's a polynomial function. The leading coefficient would be the number that's in front of that highest degree term, like 2, okay? And we'll talk about that in a second. And also, if it's a polynomial function, we'll find the zeros, the values of x that make f of x equal 0. So you set y equal to 0 or f of x equal to 0. Oops, that's misspelled. And then you find the x that makes y equal 0. So let's use that information to do example 1. Okay, so let's do example 1, where we have to find out if these are polynomials or not. And if they are, find out this information about them. The first one, like I said before, is a polynomial, even though there's a negative exponent. That's because the negative exponent is not on the variable. So over here, I really should have said that all exponents on the variables are positive integers. Right? These exponents right here are all positive integers. And so this 3 to the negative 1 is really the coefficient. If you recall from algebra, the rules of negative exponents, any base to a negative exponent is 1 over that base to the positive 1. So 3 to the negative 1 is really 1 over 3 to the positive 1, which means that this polynomial is really just 2x squared minus 1/3 x plus 4. And the degree of that polynomial is actually the highest exponent, which is going to be 2. And a degree 2 polynomial is known as a quadratic. Next, we're going to find out what the leading coefficient is, and the leading coefficient is the coefficient of the highest degree term. That would be this term, and the coefficient there is 2. So the leading coefficient is also 2. To find out what the y-intercept is, it's just the constant term, which is what you obtain when you replace all the x's with 0. When x is 0, f of 0 is going to be 4. So the y-intercept is this constant term 4. And then lastly, the zeros of this function, that's really kind of hard to determine. I'm just going to have you take a look at the graph. I have it behind it. I'm just going to move this. Yep, there it is. So the graph of this function, when you take a look at it, is a parabola, but it doesn't cross the x-axis. So I know that the zeros are not real numbers. They're non-real numbers, but I'm not going to go through finding them right now just to save time. So we're just going to say for right now that the zeros are non-real. If you take a look at this function, I can see that there is a negative exponent, and it is on the variable. So this is not a polynomial, and that's because there's a negative exponent on the variable x. If you want to circle that and explain why that's not a polynomial. So no need to answer the rest of the questions. For C, this is also not a polynomial, and that's because we have a variable in the denominator, which is the same thing as a variable to a negative exponent. So not a polynomial. This one is a polynomial, and the highest exponent is 5, so the highest exponent. So this is a degree 5 polynomial known as a quintic equation, so I'll write that down. Degree 5 quintic. The leading coefficient is going to be -2 because that is the coefficient of the highest degree term. Doesn't matter that 8 came first. So the leading coefficient is 2. And the next part we're asked to find is the y-intercept. The y-intercept here is 0 because there is no constant term, which means I'm adding 0 here. And if you replace the ends with 0, you'll get that the y-coordinate is 0. Now we're asked to find the zeros of the function, and to find the zeros of the function, I'm going to actually factor this. The greatest common factor in both terms is 2n cubed. Both of these terms are divisible by 2n cubed, so I'm going to take that outside of the parentheses. And inside the parentheses, I would have 4 minus n squared. When you distribute this, you'll end up with this. And 4 minus n squared is the difference of two squares, which I can write as 2 plus n times 2 minus n. So this breaks really into 3 factors, but this is really 5 factors. It's 2n times n times n. So there's really 3 zeros of 0 here. So the zeros of this function, if you put this first factor equal to 0, 2n cubed equals 0, n is 0. 2 minus n equals 0 means n is 2. 2 plus n equals 0 means n is -2. So the zeros of this function are -2, 2, and then 0 3 times. It's a degree 5 polynomial, which means it should have 5 zeros if you count the repeaters. Okay, so that last equation, example 1D, I actually graphed it, and you can see that the zeros are actually -2, 0, and +2. Okay, for example 2, we are asked to find P of 3 and P of -1 if P of x is 2x to the 4th minus 5x cubed plus 4x plus 3 using direct substitution. Direct substitution means just replace every x with the number you see here. And you can see that's what I've done here. Every x I've replaced with 3. This will give me 2 times 81 minus 5 times 27 plus 4 times 3 plus 3. And it ends up equaling 42 when we're all done. So P of 3 is actually equal to 42. I'll put that over here. I'm going to have you try the next one, P of -1 on your own. Okay, still for example 2, you're asked to find P of 2i. So you can see that I replaced every x with 2i. And we're going to evaluate this. We have to keep in mind the rules for I to the various exponents, okay? And we've gone over this before. So for this one, we're going to have 2 times 2i to the 4th. That means I need to multiply 2 by itself 4 times, 2 times 2 times 2 times 2, which is 16. And then I multiplied by itself 4 times. So I to the 4th, that's just 1. So I'm going to leave this as just 2 times 16 because it's 2 times 16 times 1. This one, I'm going to take away 5 sets of 2i times 2i times 2i. That's 2 that's being cubed, that's 8. And then I that's also being cubed, that's -i. So I'm going to put here 5 times 8 times -i. This just gives me 8i, 4 times 2i. And then I have the constant term 3 at the end. Start cleaning it up. This is just 32 minus 40 times -i. So I'm going to have minus negative 40i, because it's take away a negative, so that's really 32 plus 40i. Then I add 8i and add 3. So when I combine my like terms, I have 32 plus 3, which is 35. And I add that to 40i plus 8i, and that gives me 48i. So when I evaluate P of 2i, it comes to 35 plus 48i. Okay, example 3 has the same exact function and the same exact numbers that we're supposed to plug into them, 3 and negative 1, only we're supposed to do it synthetically instead of directly. Instead of directly plugging in numbers, I'm going to use synthetic substitution, which means I need to be concerned with the coefficients of x to the 4th, which is 2, x to the 3rd, the coefficient is negative 5. The next exponent would be x squared, but I don't have any x squareds, so it's 0 x squareds. I need to put that placeholder in there. The next one is x to the 1, and the coefficient there is 4. And the constant term is 3. So what I do now is I put those into my synthetic substitution. It almost looks like synthetic division for polynomials. I'm plugging in 3, so that's the number I'm going to put out here. I'm going to make another line underneath. And what I do is I bring the first number down. The first coefficient always comes down. And if you recall the process is to take the number that's under here and multiply it by whatever's here. So 2 times 3 would give us 6, and we put it here. So times 3. And then on the way down, I add. When I add negative 5 and 6, I get 1. And that number now gets multiplied by 3. Everything here gets multiplied by 3. And 1 times 3 would give me 3. And then I add on the way down. 0 plus 3 is 3. Now this number gets multiplied by 3. 3 times 3 is 9. Put it here. And add on the way down. 4 and 9 gives me 13. 13 now gets multiplied by 3 and put here. 13 times 3 is 39. And when you add 3 to 39, you get 42, which means that P of 3 is 42. And that's exactly what we got in example 2 for P of 3 when we plugged it in directly. Now let's do P of negative 1 to see if you got your own P of negative 1 correct. Okay, so for example 3, now let's do P of negative 1. You'll see I still have the same coefficients, 0x squared, 4x's constant term is 3, but this time I put negative 1 out here. And so now I am going to make another row here. The first number comes down. The leading coefficient of 2 comes below the bar. Every number that's down here now gets multiplied by negative 1. 2 times negative 1 is negative 2. And then I add on the way down. Negative 5 plus negative 2 is negative 7. And now I take this number and multiply it by negative 1. Negative 7 times negative 1 is positive 7. Add on the way down, 0 plus 7 is 7. Take this number now and multiply it by negative 1. 7 times negative 1 is negative 7. Place it under the next coefficient. And then add 4 to negative 7, and I get negative 3. Now I multiply negative 3 times negative 1 to get positive 3. And when I add 3 to positive 3, I get 6, meaning that P of negative 1 should be 6. You should have gotten the same thing when you plugged in negative 1 directly. You should have gotten that P of negative 1 equals 6.